We're going to use the definition of the derivative to differentiate f of x equal to the square root of secant of x. Now to do it, we'll require three results. The first one is the trig identity of cosine of alpha plus beta equals cosine of alpha times cosine of beta minus sine alpha times sine beta. The second result we'll need is the limit as h approaches 0 of 1 minus cosine of h divided by h equal to 0. And the third result, the limit as h approaches 0 sine of h divided by h equals to 1. Let's recall the definition of the derivative. F prime of x is defined as the limit h goes to 0, f of x plus h minus f of x divided by h. So in our case, where f of x is the square root of secant of x, this becomes the limit as h goes to 0 of the square root of secant of x plus h minus the square root of secant of x divided by h. Now, first step is to multiply this by the conjugate of the numerator, which is the square root of secant of x plus h plus the square root of secant of x. And of course, we can't just do that. We have to also divide by the very same thing so as to not change the problem. So this is divided by square root of secant of x plus h plus the square root of secant of x. And this is equal to, the numerator will not have any radicals in it because of the selection of the conjugate. So this, the numerator is just secant of x plus h minus secant of x. And the denominator is h times the quantity square root of secant of x plus h plus the square root of secant of x. The next step is to change secant into 1 over cosine. So this now looks like the limit as h goes to 0, 1 divided by cosine of x plus h minus 1 divided by cosine of x divided by h times the square root of secant of x plus h plus the square root of secant of x. And now what we're going to do is have a common denominator there in the numerator. We'll multiply this by cosine x over cosine of x, and 1 over cosine by cosine of x plus h over cosine of x plus h. And now the next line is the limit as h approaches 0. We have cosine of x minus cosine of x plus h divided by cosine of x plus h times cosine of x, and then the whole thing is divided by h times square root of secant of x plus h plus the square root of secant of x. Now let's apply the identity to cosine of x plus h. So alpha is x and beta is h. And this is the limit as h approaches 0. We have cosine of x minus the quantity cosine of x times cosine of h minus sine of x times the sine of h. And the two denominators can be combined into one. We can write it as h times cosine of x plus h times cosine of x times square root of secant of x plus h plus the square root of secant of x. The next step is to simplify the numerator. And this is the limit as h approaches 0. We have cosine of x minus cosine of x times cosine of h plus sine of x times the sine of h. And this is divided by h times cosine of x plus h times cosine of x times the square root of secant of x plus h plus the square root of secant of x. Notice that these two terms have cosine of x in common, so we're going to factor out cosine of x. We get limit as h goes to 0, cosine of x times 1 minus cosine of h plus sine of x times sine of h, and this is divided by h times cosine of x plus h times cosine of x times the square root of secant of x plus h plus the square root of secant of x. And let's write this now as a sum of two limits. The first limit is going to be limit h goes to 0, cosine of x times 1 minus cosine of h, and this is all divided by h times cosine x plus h, cosine of x times the square root of secant of x plus h plus the square root of secant of x. And the second limit is going to be the limit as h goes to 0. We have sine of x times the sine of h divided by h times cosine of x plus h times cosine of x times square root of secant of x plus h plus the square root of secant of x. And now let's break these up or write these as product of two limits each. The first limit here is limit h goes to 0, 1 minus cosine of h over h times the limit h goes to 0 of cosine of x divided by cosine of x plus h times cosine of x. You can see we can cancel these, times the square root of secant of x plus h plus the square root of secant of x. So that's the first limit, is a product of two limits. Let's look at this one first. Notice that this limit here is result number 2. This limit is 0. So this limit will be 0 times, we have 1 in the numerator. In the denominator we have cosine of x, and then we have square root of secant of x plus the square root of secant of x. So you can see 0 times this will be 0, and the first limit is 0. This whole thing goes to 0. So all we have to do is now worry about the second limit, which we can also write as a product of two limits. The first of these limits will be the limit as h goes to 0, sine of h over h. That's result 3, and this limit goes to 1. And so the remaining answer will be the limit h goes to 0. We have sine of x in the numerator. In the denominator we have cosine of x plus h times cosine of x times the square root of secant of x plus h plus the square root of secant of x. And now let h go to 0, and we have the following answer. The numerator is sine of x. The denominator we have cosine of x times another cosine of x times the square root of secant of x plus the square root of secant of x. And let's simplify this. This is equal to 1 over cosine is, well, let's write it like this. 1 over cosine of x times sine of x over cosine of x, and then times 1 divided by 2 square root of secant of x. And we can certainly simplify this. 1 over cosine is secant of x. Sine over cosine is tangent of x. And then in the denominator we have 2 times the square root of secant of x. And that's the final answer to the question to finding the derivative of square root of secant x by definition. To summarize, if f of x is equal to square root of secant of x, using the definition we found the derivative to be secant of x times tangent of x divided by 2 times the square root of secant of x. For more videos, visit www.mathprepvideos.com.